Hello students, now in this video let us see combinations with repetition. Now it is not like a permutation. There is a theorem, there is one rule. If there are n types of objects, then are objects with repetition allowed can be selected from these n types of objects in C n plus r minus 1 r ways. That is same as to say the corollary for this theorem. This is the formula for n types of object, and r object with repetition we have to select from this. Fine. So now the corollary for this, let n and r be given positive integers. Okay. Then the number of non-negative integer solutions x1, x2 and so on up to xn of the equation x1 plus x2 plus so on up to xn equal to r is, this is same as to say the solution for this equation is C n plus r minus 1 r. These are both the things are equivalent. So here also for each place, for each one we have the r. This repetition allowed, so n types of elements and we have to select r elements with repetition. So then any r combination n elements with repetition corresponds to the solution of this kind where each xi is greater equal non-negative. So greater equal what? 0. That is it is a solution for the equation what? Which equation? This x1 plus x2 plus so on up to what? xn equal to r with xi greater equal what? 0. Fine. Now let us take the example on this. Example, suppose the example says, suppose how many ways are there to pick a collection of 10 coins from piles of pennies, nickels, dimes and quarters. We have to select coins from piles of these materials. Fine. So solution for this one. Now how many types of objects with us? So 4 different types of objects with us: pennies, nickels, dimes and quarters. So here n equal to type of coins. Type of coins are how many? 4. And we have to select how many? 10. And we want to select 10 coins. Here that is 10 coins we have to select, means what? That is what? R is equal to what? 10. Therefore number of ways, it is obviously here the repetition may allowed. Fine, we can select 10 coins out of these 4 coins. So 10 coins select, and type of coins are how many? 4 only. So obviously the repetition is allowed. So number of coins or number of ways of such a selection, number of ways of selection of such a coin are how many? C n plus r minus 1 comma r. Selection means combination and repetition allowed, so this is a result for that. So C, that is same as C. What is n? 4 plus r is 10 minus 1 comma 10. So this is 14 minus 1, so 13. So C 13 comma 10. This is the answer here. Fine. Now let us go for the next example. A very simple thing is this. Later on we will go for the examples on the corollary also. So first of all let me take examples on theorem. So next example. How many ways are there to select a committee of 15 politicians? 15 politicians chosen from a room full of indistinguishable Republicans and indistinguishable independents. If every party must have at least two member on the committee. Now here we have to select a committee of 15 politicians. Fine. So from where? From the room with some of the Democrats are there, but these are indistinguishable, they cannot be distinguished. Again some Republicans are there and some independents are there, and every party must have at least 2 members on the committee. So first of all, 2 members of each party. We first include 2 members of each party on the committee. After including 2 members of each party on a committee, so means from 15 3 different parties are there. So from 15 we should subtract 6 people. So 9 politicians from 3 different types of parties later on we have to select or we have to choose. After first of all include 2 members from each party on a committee. So here solution we can write. We first include 2 members of each party on a committee. Therefore, we have to choose 15 minus 6, each for 3 different parties are there, each having 2 members, so 3 to the 6 we have to subtract. So remaining are only 9 politicians from 3 different types of parties. 3 types of parties. But while doing that, obviously the repetition is allowed. So therefore what we get here, n is equal to 3. 3 different parties are there. Fine. So n is equal to 3 and 9 will be what? Our r. 9 selections we have to do. So r will be 9. Fine. Therefore number of ways, as the repetition is allowed, so number of ways of such a selection are how many? C n plus r minus 1 comma r. So what is C? N is 3 plus 9 minus 1 comma r. So it will be C. This is 11. R will be 9. 11 comma 9 or 11C 9. This is the answer here. Now let us go for the question of the kind or question of containing the equation. Let me take that kind of question also, or on a corollary, question on a corollary. So the question is that how many integer solutions are there to the equation x1 plus x2 plus x3 plus x4 equal to 17 with xi greater equal 0. This is the first one, suppose, and the second one is here. Second one, how many solutions with xi greater equal 1 also we have to find out. Fine. So solution is here. Look at here. Now you know, if x1 plus x2 plus integer solutions we have to find. If such a relation is there or such a equation is there with xi greater equal 0, so here the number of variables is nothing but our n number of variables, and right hand side denotes r. Fine. So if we compare with that one, what is n here? N is equal to 4 and r is equal to what? 17. If such a things are there, the number of number of integer solutions are these, n plus r minus 1 comma r. These many number of solutions are there, integer solutions basically. So if we compare with this, the solution of first one, what can we say? The solution of first one here, n is equal to what? 4 and r is equal to 17. R is 17. Therefore number of solutions equal to C n plus r minus 1 comma r, that is C 17 plus or 4 plus 17 minus 1 comma 17. So that is C 20 comma 17. Okay. Now for the second one, this is the answer of first one. It is very easy. Now but for second one, the condition is xi greater equal 1 is given. We have this, these are the solutions for xi greater equal 0. These are for non-negative integer solutions, but not for non-zero integral solutions. Fine. So for that, what we have to do here, we can do the substitution. Here we can put yi is equal to xi minus 1. If I put, look at here, xi greater equal 1, but xi minus 1 is what greater equal 0. So I will take this element as y greater equal 0. So yi is equal to xi minus 1 I will put up here. So that is same as, or this is greater equal 0. Okay. So as yi what greater equal 0. Fine. Since xi greater equal 1 we can say here. Fine. That is same as to say xi is equal to what? Yi plus 1. So we will put this in equation. Put in given equation. Put this thing in given equation. After substituting this in given equation, how does the given equation become? Look at here. Xi equal to yi plus 1. So what is x1? x1 is equal to y1 plus 1. I at same. x2 is equal to what? y2 plus 1. x3 is equal to what? y3 plus 1. x4 is what? y4 plus 1. As we have to do the substitution. So substitute x1, x2, x3 and x4 in this equation in terms of yi's. Therefore we get y1 plus 1 plus y2 plus 1 these plus y3 plus 1 plus y4 plus 1 equal to what? 17. So this gives us y1 plus y2 plus y3 plus y4. Now this 1, 1, 1 and 1. This is 4. So 17 minus 4. So this will be 13. And we know yi is what? Greater equal 0. So this is our new equation. It gives us a new equation with, now here n is equal to what? Again 4. But r is now 13. This is a new equation with n is 4 and r is 13. Again solve just like this. Therefore what we can say, number of solutions, therefore number of solutions of such equation, number of solutions of such equation are what? C n plus r minus 1 comma r. But now n and r will be changed, n will remain same. So C 4 plus 13 minus 1 comma 13. So this is C, how much? This is 17 minus 1, so 16 comma 30. This is the answer here. As such we can solve or we can find the integer solutions for the different equations also using the same formula for repetition in combination. Now let us write down one note, the equivalent form of selection with repetition. Now the same thing can be asked in different ways. How does they? So let me give that as a note to you. Various forms or the equivalent forms. Equivalent forms of selection of or selection with repetition. Selection with repetition. So actually first form, the number the number of ways to select are objects. Number of ways to select are objects of type 1 are objects with repetition from n different types of objects. Okay, then the second kind or the second equivalent form, the number of non-negative integer solutions. Integer solutions to x1 plus x2 plus so on up to xn equal to what? R. And the third one, the number of ways to distribute are identical objects into n distinct boxes. So either selection of R objects or either finding the number of non-negative integer solutions or distribution of R identical objects, these are equivalent to say the selection with repetition. So same result of combination, that C n plus R minus 1 comma R will be applicable to all these forms. Okay, so here we will stop. In next video we will see permutation with indistinguishable objects. Thank you.